Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about the alpha decay. So what is alpha? What are alpha particles and what is alpha decay? So what happens, as we discussed in the previous video, that when the heavier nuclei, they are unstable because of the greater number of protons as compared to the number of neutrons. That means the proton to neutron ratio is higher. Your nucleus is unstable, and in that case an alpha particle is emitted from the nucleus, and whatever is your resultant nucleus, so your decaying nucleus is going to turn into a different nucleus. So your decaying nucleus is the parent nucleus, and it will turn into a different nucleus, which will be the daughter nucleus. And this alpha decay happens when the proton to neutron ratio is higher. So we must remember that this is a basic concept, that proton to neutron ratio is higher means there's a greater number of protons. So an alpha decay is going to happen. So what is an alpha particle? So basically an alpha particle, its configuration is same as that of a helium nucleus. So we say 2He4. That is, alpha particle consists of 2 protons and 2 neutrons. So when an alpha decay happens, you will say that you have 2He4 being lost. So there would be a general equation that your starting parent nucleus, which was ZXA, Z its atomic number and A is mass number. The moment it releases an alpha particle, it is going to have a new nucleus, a different nucleus called the daughter nucleus, say Y, and released particle is 2He4. Now we know that according to the conservation of charge on both sides, so if the total number, atomic number or total number of protons was Z initially, total has to be Z finally as well. That means the daughter nucleus is going to have Z minus 2 protons, because this Z minus 2 plus 2 will give you Z again. So total has to be Z on the left side, total has to be the Z on the right side. And similarly for the mass number, you have A here. So the released particle has 4 as the mass number. So the daughter nucleus should have A minus 4. So this is your general equation that represents an alpha decay. So you have ZXA giving you Z minus 2, Y A minus 4 plus 2He4, that's the helium nucleus or an alpha particle. So A minus 4 plus 4 gives you A on the right side, same as that on the left side, and Z minus 2 plus 2 gives you Z on the right side, which is same as that on the left side. So let's see, for example, you have the starting parent nucleus as 92U238. When it undergoes an alpha particle decay or alpha decay, this is going to give you 2He4 as the alpha decay. So as per the general equation, the other element, new daughter nucleus formed is thorium. It should be 90 thorium 234. So you have 234 plus 4 as 238 and 90 plus 2 as 92. This 90 thorium 234 is still unstable and it will undergo one more alpha decay. So you will have 2He4 again released and you get a new particle, that is radium, so which is 88 and 230. So that means your uranium 92U238 finally changes to 88 radium 230 by subsequent emissions of 2 alpha particles. So first alpha particle emission gives you 90 thorium 234. The next alpha particle emission gives you, from 90 thorium 234, you get 88 radium 230. So I hope you've understood that why alpha decay happens and how the alpha decay happens and what equations represent the alpha decay. So that's all for this video session. In the next video session, you are going to learn about the beta decay. Thank you for watching.